Design and Technology is an elective subject for Form 1 to Form 3 students, aimed at fostering creative thinking, technological awareness, and problem-solving skills for real-world application. One of the key topics in this subject is electronic design, where students are introduced to basic circuit concepts, electronic components, and control systems. According to the Form 2 Design and Technology Curriculum and Assessment Standard document, the topic of electronic design comprises 8 subtopics, including an introduction to microcontroller components, circuit drawing, circuit simulation, circuit connections, writing programming code, testing, and improving existing products. Besides that, technology-based learning methods create engaging learning experiences and encourage students to learn abstract concepts. In addition, Augmented Reality (AR) enables students to build visual experiences of basic programming concepts in 3D, thus facilitating a better understanding of abstract ideas. To enhance understanding of this topic, we have developed an innovative teaching aid known as iCodeAR. To support this learning, we developed iCodeAR, an interactive teaching aid that combines smartphone technology, augmented reality (AR), and robotics. This innovation aligns with the 1010 STIE framework, empowering students to explore, understand, and apply technology in meaningful ways to make learning hands-on, immersive, and future-ready. Richard Mayer's connective theory of multimedia learning explains how students process information from educational materials such as text, images, audio, and digital objects. According to this theory, humans learn through 2 primary channels, the verbal channel for words and narration, and the visual channel for pictures and graphics. In interactive learning, a third channel, namely touch or haptic interaction, may also be activated, such as when students physically engage with objects or robotic devices. However, our working memory has limited capacity. Too much information at once can lead to cognitive overload. That is why multimedia content must be designed thoughtfully, showing only essential elements to support focused learning. To truly learn and retain information, students must go through 3 active processes: selecting relevant input, organizing it into mental models, and integrating it with prior knowledge. Through this approach, innovations like iCodeAR support Mayer's theory by delivering content through visual, auditory, and tactile experience. In other words, making abstract topics like programming and microcontrollers easier to understand and far more engaging. iCodeAR was developed in alignment with the Form 2 Design and Technology Curriculum and Assessment Standard document. The design of this module is divided into 5 main components. The first one, Introduction to Microcontrollers and Microprocessors. Second, Input and Output Components. Third, Basic Connection Flowchart. Fourth, Additional Components for Circuit Connection. And lastly, Fundamental Programming Structures. The orange-colored card represents the first structure in this module, which is the Introduction to Microcontrollers. The green and blue cards represent the second structure in this module, which is the Input and Output Components. The purple card represents the third structure in this module, which is the Basic Connection Flowchart. The pink card represents the fourth structure in this module, which is the Additional Components for Circuit Connection. And the red card represents the fifth structure in this module, which is the Fundamentals of Programming. iCodeAR flashcards can be played like a regular card game, where players arrange the stars on each card to match a specific predetermined logo pattern. When the cards are arranged according to the designated logo pattern, they form a structured visual node that delivers key learning content. In addition, each card can display augmented reality content through smartphone scanning. This feature helps novice students to visualize electronic components more clearly, making the module more engaging and interactive. The robotics element is used to help students directly observe the outcome of the program they have created. Simulation-based exercises are also provided through the use of the Tinkercad application, allowing students to design and test circuits virtually before applying them in real-world situations. Why do you need iCodeAR? First, learning becomes more fun and meaningful. Second, encourages information repetition through game-based elements. Third, offers an innovative 21st century learning experience. And lastly, easy to use both in the classroom and at home. iCodeAR was developed using the AD instructional design model as the main framework. In the analysis phase, 3 RBT teachers were consulted to carry out a need analysis. The findings revealed that all 3 teachers strongly agreed on the need to develop the iCodeAR module to help students better understand electronic concepts and programming. During this phase, the essential elements required for the development of iCodeAR were also identified through interview sessions with all 3 teachers. In the design phase, the structure of the iCodeAR module was systematically planned based on the information gathered during the analysis phase. In development phase, the flashcards were designed using Canva, Adobe Illustrator, and Photoshop. The completed designs were then printed using an Epson printer. The AR displays was designed using Fusion 360 software to create 3D objects. These 3D models were then uploaded to the Sketchfab library to enable scanning and AR display functionality through the flashcards. The design and printing of the robot were carried out using Fusion 360 software to create the 3D model, while the physical printing process was done using a Bamboo Lab 3D printer. Tinkercad was used for virtual circuit simulation, while Arduino IDE was used for programming and testing on real hardware. The implementation phase involved the direct use of iCodeAR module during classroom learning sessions. A total of 3 design and technology teachers and 66 Form 2 students participated in this phase. The evaluation phase was conducted to assess the usability of the iCodeAR module in enhancing students' understanding and its functionality for classroom instruction. The evaluation involved interview sessions with the 3 RBT teachers and a questionnaire distributed to 66 secondary school students. The iCodeAR module has proven its usability in enhancing the understanding of basic programming and electronic design concepts. The use of augmented reality and robotics make learning more engaging while increasing students' interest and confidence. Through its visual and interactive approach, students are able to grasp programming structures more easily, practice independently, and respond accurately to related questions. Overall, iCodeAR has great potential as a teaching aid that supports 21st century learning. iCodeAR is more than just a learning module. It has proven its functionality by winning 2 prestigious awards during the final year project colloquium in the Best Research on Innovation Award and the Gold Award for the final year project in the Bachelor of Education in Invention. These recognitions highlight the great potential of iCodeAR as a technology-based teaching tool for 21st century learning.